In this video, I'm going to go over the basic components of an inference to the best explanation, IBE for short. I realize there's an awful lot going on this single sheet of paper, and in fact, I can barely fit it in a single screenshot. Some of the type might be a bit too small, in fact. But let me point out here quickly that this exact sheet is actually posted in the 13.4 lecture notes in this week's module. So if you're missing anything here, if you can't quite see it, if it's just too much going on one page, it's the 13.4 lecture notes. So you might want to open that up in another window, and then on a separate window, a second window that is, follow along as I go through it. Let me also point out that you'll be asked to structure an inference to the best explanation on this week's quiz. And really, you need to be able to format it exactly as I've done here. And above all, you need to be able to go through the 4 criteria listed here at the bottom. So let's start at the beginning. Just what is an inference to the best explanation? First of all, inference to the best explanation is an inductive argument form. So the conclusion here is going to be likely. It's not deductive. It's not something that's going to follow necessarily. But again, let's start at the beginning. Just what is this IBE other than being an inductive argument form? An IBE tells you which hypothesis H to infer from the available evidence. It says simply that you should infer the hypothesis that best explains E. And E is the explanandum. And here, notice I'm tying in some vocab from Chapter 1, Section 2. I know it's been a while here. But what should be clear at this point in the quarter is that even though we've taken these chapters in isolation, here's chapter 1, here's chapter 13, that it's going to all start to tie together. So let's break this down one step at a time. There's your formal definition, but still at this point it might be kind of mysterious. So E, the explanandum, is that which we know to be true. We've observed it, it's an established fact. And yet E requires an explanation, the explanans. And again, I'm tying this into 1.2. From 1.2, the explanans is a statement or group of statements that purports to do the explaining. So we've got E, some established fact, something that we know to be true, maybe even something that we've seen with our own 2 eyes. And this fact, E, the explanandum, requires an explanation. So we're going to consider competing hypotheses, competing theories, that is, that can explain E. So H will stand for our hypothesis, and we might have H1, H2, H3, so on and so forth. Hypothesis 1, hypothesis 2, hypothesis 3. And we want each to be able to explain E. E we know, and the hypothesis, the explanans, claims to explain E. So given that we have multiple hypotheses, how are we going to declare a winner? How are we going to say something like H1 is probably right and these other 2 are probably wrong? And remember that it is inductive. It won't allow us to definitively say this one is 100% true and these other 2 are completely wrong. Doesn't have that sort of ability, if you will. It is, again, let me emphasize the point, an inductive argument. So what we want to do here is make an inference to the best hypothesis, the best explanation, that is. So what criteria are we going to use to declare one of these to be better than the others? And this is all listed here in Chapter 13. We want our hypothesis to be internally coherent. We want it to be externally consistent. We want to, actually I skipped one. We want it to be able to explain E, first of all. We want it to that is, have explanatory power. And the term used here in Chapter 13 is adequacy. So we want it to have explanatory power, internally coherent, externally consistent. And then I'm tying in a concept from earlier in the quarter, There's a separate video tackling this one all by itself, namely Occam's razor. So whichever hypothesis best fits each of these 4 criteria, we're going to infer is the best one. So those are the guidelines, if you will. And I've provided a little bit more detail on each of the 4 criteria here at the bottom. Again, this is from the 13.4 lecture notes posted in the module. And again, you'll be required to go through this for the quiz. I'm going to give you a problem, and you're going to come up with the best explanation to explain this. So, number 1, adequacy, as I've referred to it, explanatory power. We want our hypothesis to be able to explain E. We want, that is, a hypothesis to fit the facts that it's intended to explain. So adequacy, read explanatory power. If we've got one hypothesis, H, that can explain everything, and the other 2, maybe H1 and H3, have limited explanatory power, or that is limited adequacy, then this might very well be as deep as we need to go. If one hypothesis can explain a bunch of stuff, and the other hypotheses have very limited explanatory power, then obviously we're going to go with the hypothesis that has the greater explanatory power, provided that, number 2, it's internally coherent. And by internally coherent, and you see a long-winded definition here, read it in the 13.4 lecture notes. For internal coherence, we mean that we don't want the hypothesis to contradict itself. If a hypothesis is self-contradictory, it contradicts itself, that is, then it's not internally coherent. So we want to be able to put a big fat check here. We want it to be able to explain everything that we know to be true, and certainly we don't want it to contradict itself. And I've given you a little bit more detail here. Internal coherence, notice, is a necessary condition for truth, but it's not a sufficient condition. And again, I'm tying in lingo, putting all the pieces of the puzzle together here for one big inference to the best explanation. This lingo is from chapter 1 again. And in fact, that was a part of the first test, if you remember. Again, internal coherence is a necessary condition for truth, but it's not sufficient, which is to say, you can read about this more in the lecture notes, but that's to say that if a hypothesis is internally consistent, it doesn't necessarily mean that it's true. Just because it's internally consistent doesn't mean that it's true. You could tell a story which is in fact internally consistent, which doesn't contradict itself, and yet isn't at all true. And as an obvious example, just take a good movie. A pure piece of fiction, or a novel for that matter, it doesn't contradict itself. It tells a coherent story, but it's just, again, a pure piece of fiction. All the details fit together, it makes perfect sense, it's an entertaining story, doesn't contradict itself, but it doesn't correspond to truth. So internal coherence is not a sufficient condition. Just because it's internally coherent doesn't mean it's true. However, internal coherence is a necessary condition for truth, which is to say, if a theory is true, it's got to be internally coherent. So our hypothesis has to be internally coherent. But again, just because our hypothesis is internally coherent doesn't mean that it's true. We then need to dig a little deeper. A couple of other criteria listed here. Number 3, and no real order, we want our hypothesis to be externally consistent. Externally consistent. Number 2 here, we don't want it to contradict itself. And number 3, we don't want it to contradict other things we know to be true. So our hypothesis might be off to a good start. Okay, it explains E, great. It doesn't contradict itself. But what if our hypothesis contradicts something else we know to be true? Well, now we got a problem. We don't want our hypothesis to be inconsistent with other well-established facts. We want it to explain the current E, but we don't want it to conflict with other E's, if you will. So we need to put a big fat check there. And we might have to get all the way down to number 4. It could be the case that we have two hypotheses that have explanatory power. They can both perfectly well explain E. It could be the case that neither is self-contradictory. So at this point, we'd have a tie. We've got H1, we've got H2. Both adequately explain E. Neither is internally inconsistent. So we'd have a tie here. Neither conflicts with other things we know to be true. So if we need to, we'll get all the way down to 4, Occam's razor. And just this situation, two competing hypotheses, they are both internally coherent, they are both externally consistent. How at this point are we to adjudicate between the two? Well, at this point then, we would apply Occam's razor. And again, there's a separate video covering this, but just a quick little recap. We would apply this given equal adequacy, equal explanatory power. We're simply going to pick the hypothesis that takes on the fewest number of underlying assumptions. We're gonna pick the more elegant, the more simplistic hypothesis, if you will, the one that has the least amount of, here's the fancy phrase, ontological baggage. So there's the basic structure of an IBE. Read about this, obviously. There are a couple other videos, and I'm going to create a different video going through a particular example. And again, that's what you're going to have to do for the quiz. You're going to have a quiz question, and you're going to have to think your way through it using these basic tools, using an inference to the best explanation.